All right, today we are diving deep. We're going right inside the syringe to uncover the secret science of dermal fillers. It's this incredible space where chemistry meets aesthetics, and really understanding it can make all the difference.
You see them everywhere, right? Fillers promise to restore volume, sculpt features. They're more popular than ever. But that brings up a really important question. Are they all just the same? I mean, on the surface, it's just a clear gel in a syringe. But what's the hidden science that makes one filler perfect for creating soft, pillowy lips, and another one strong enough to literally build a jawline? Well, that is the mystery we are solving today.
Okay, so here's our game plan. First, we're going to look at what's actually inside the syringe. Then we'll decode each filler's unique personality. After that, we'll see how to match that personality to the right spot on the face, explore the super important undo button, uncover a key manufacturing secret, and wrap it all up with how you can use this science to have a much smarter conversation with your provider.
So first things first, what is actually in that syringe? The answer really comes down to one incredible powerhouse molecule.
The absolute star of the show is something called hyaluronic acid, or HA for short. Now, this is a type of sugar that your body already makes. Its superpower is that it binds to water like a magnet, and that's what gives our skin that amazing moisture and plumpness. But here's the catch. In its natural state, it doesn't stick around. We're talking a half-life of less than a day sometimes. So to make it last for months or even years in a filler, scientists use a process called cross-linking. It's like tying all the HA chains together with tiny chemical bridges to make the gel way more stable and durable.
But here's where it gets really interesting. Not all of these HA gels are created equal. They have totally different consistencies, different strengths. You could almost say they have different personalities. And the scientific term for this personality is G'. This is probably the single most important property you need to understand.
So G', it sounds super technical, right? But all it really is a measure of the filler's firmness and strength. It tells you how well the gel can hold its shape and resist getting squished. Think of it this way. A high G' gel is like a sturdy support beam, while a low G' gel is more like a soft, squishy cushion.
To really get a feel for this, let's use some analogies. A low G' filler is soft and runny, almost like chewed gum. It spreads out easily and doesn't really hold a specific shape. On the flip side, a high G' filler is robust, kind of like a rubber band. It snaps back, it holds its shape, and it has real structural integrity. Okay, so you get it now, right? This G', this personality, is a huge deal because you absolutely cannot just stick any filler anywhere on the face. It is all about matching the right tool to the right job. Let's see how that works. Let's start with the low G' fillers. These are your soft, watery gels. They're perfect for delicate areas and for etching away fine lines, usually placed right near the skin surface. And because they're so flexible, they move naturally right along with your expressions, so you don't get that stiff or weird look.
Moving on up, you've got your medium G' fillers. These guys strike that perfect balance. They have enough body to add some volume and shape, but they're still soft enough to look and feel totally natural. This makes them a go-to choice for places like the lips, where you want some plumpness, but you still need that soft, natural movement.
And finally, we get to the heavy hitters, the high G' fillers. These are all about creating structure. They're the thickest, firmest gels, and they get placed deep, often right on top of the bone. They act like an internal scaffolding to lift tissues and really sculpt out features like the chin, the cheeks, or the jawline.
One of the absolute best things about HA fillers, what makes them so different from other types, is that they are reversible. Yep, there is an undo button. And let me tell you, that is a critical safety net for either fixing a result you don't love or, more importantly, managing complications.
So what is this magic undo button? It's an enzyme called hyaluronidase, and you can literally think of it as a pair of molecular scissors. When it's injected, it specifically hunts down and snips apart the hyaluronic acid in the filler, dissolving it so your body can just absorb it. It is the essential antidote that makes HA fillers so safe.
But this whole idea of dissolving fillers, it brings up a really fascinating question. If you can dissolve them, does that mean they all dissolve the same way? Are some easier to erase than others? Well, a major study in 2024, published in the Aesthetic Surgery Journal, set out to answer exactly that.
The big question the researchers had was this. What really determines how hard or easy it is to dissolve a filler? Is it how much HA is packed into the syringe? Maybe it's the length of the HA chains themselves. Or is it all about how much of that chemical cross-linking is holding it together? They took 16 different fillers and put them to the test.
First, they looked at HA concentration. If you look at this chart from the study, you can see the dots are just all over the map. There is no clear pattern at all. A high concentration didn't necessarily mean it was tougher to dissolve. So, no, that wasn't the secret.
Okay, so what about the length of the HA chains? They tested that next. And same story. Look at the chart. Long chains, short chains. They're scattered everywhere. No obvious connection here either. So, strike two. That wasn't it.
All right, last shot. What about the degree of chemical modification, that cross-linking we talked about? And you probably guessed it. Once again, the data shows no predictable pattern. So if it wasn't any of these individual things, what in the world was it?
And here's the big reveal. It turns out it's not about any one ingredient. The single most important factor is the proprietary manufacturing technology. The whole recipe, the entire process that a company uses to create the gel. And this chart says it all. Look how the fillers cluster together perfectly, not by ingredient but by their manufacturing family. That was the secret.
This table basically breaks it all down for us. The study found this clear hierarchy. At the very top, you have fillers made with Vicross technology. They were by far the hardest to dissolve. And way down at the other end, you have the CPM technology, which dissolved the fastest. Everything else fell somewhere in between, each with its own unique personality when it comes to being reversed.
So, what's the bottom line here? What does all this science actually mean for you? It means you can walk into a consultation not just as a patient, but as an informed partner in your own treatment plan. This is how you can completely change the conversation. Instead of just asking for a brand you saw online, you can ask about the technology behind it. You can ask, what's the G prime of this product? You can discuss how its properties are the perfect match for your goals. And crucially, you can talk about what its degradation profile means for both how long it will last and, just as importantly, for safety.
And all of this leaves us with one final, really important question to think about. We've just learned that the fillers that are the most durable and last the longest are also the most difficult to erase. So in the world of aesthetics, where safety is everything, is a longer-lasting result always the better choice? It's a critical trade-off to consider, isn't it?